here's what we need to know. Okay? First of all, is water going to be a major species?
No.
It is present in large quantities. Does it affect the concentration? Not particularly. Okay? In this case, we would say probably water, not a major species. Just happens to be what the reaction's taking place in. Is formic acid going to be a major species? Now, another question for you. Which is going to be present in larger amount? Formic acid or hydronium and formate ion? Which is there going to be more of? And how would you know the answer to that without knowing anything else? Well, to answer that question, we need to answer this question first. Is formic acid a weak acid or a strong acid?
Oh, you said without knowing anything else. I thought that included not knowing strong acids.
Well, okay. Let's say without knowing any numeric values, which I don't happen to have off the top of my head. But let's look at it from this point of view. Is formic acid a weak acid or a strong acid?
Weak.
How do you know that it's a weak acid? Because it's not one of the 6 strong ones. Good. That's an overly simplistic answer that surprisingly is right most of the time in this conversation. If it isn't one of the 6 strong ones, it's a weak one. The only real exception to that is like phosphoric acid for the first deprotonation, but more on that later. Okay? So, this is a weak acid. What do we know about weak acids as far as the extent of dissociation? What are you thinking? They don't dissociate all the way. Incomplete dissociation. Usually for weak acids, what we think of is probably 1% dissociation or less. Okay? So, which are we going to have more of when we get done? Formic acid or hydronium and formate? Formic acid. We're going to have a lot more of this that remains undissociated than we will have of the dissociation products. Now, which of those is going to be necessary to determine the pH? We've already eliminated water. Water's not going to determine the pH. Of the 3 things that remain, what is? Hydronium ion concentration. Okay? This, which is the same thing as that, this is going to determine pH. So, as we are doing our calculations, we'd better make certain that this is represented someplace. If we don't know how much of that there is, there just simply isn't any way that we can determine what the pH is. Just can't do it. That's a vital, essential piece of information we've got to have. Now, if we know what that is, we're going to know what that is by stoichiometry. It may not be something specifically that is of interest to us, but knowing that it's the same as this is probably going to prove useful. And then this, we're going to need to know how much we started with. Because by knowing how much we started with, if we happen to know what the Ka value is, and in most cases we can just look that up, we can determine the extent of dissociation from that. Okay? So, in this case, in order to solve a problem of what would the pH of this solution be, these are the quantities we really need to know. Water, yeah, it's there. It's mostly what is there. But we don't need to really know how much, other than it's enough to contain the rest of the reaction. Okay? Any questions at this point? Let me tell you what we're looking at next time. Next time we are going to begin doing calculations involving these. What we will do is we will set up Ka expressions. You remember K expressions, equilibrium expressions? What do we put on top? Products on top. reactants on bottom, which we'll never have to worry about that, because water's going to be a liquid. So ultimately, our Ka expression is going to boil down to Ka equals this concentration times that concentration, maybe with exponents, over this concentration. And how do we solve a problem like that? What mechanism did I teach you to use to do that? The ice box. Okay? So, dig up your notes on ice boxes. We're going to dive right into them next time. Fair enough? Let me give you some new problems. Because there are a few new problems you can do now. This will be in addition to the ones which are up there. We already have problems 21, 22, 25, 29, 30, and 31. I'm going to add today the following. Let's include 37, 38, 39, and 41. And oddly enough, these are already up on the wiki. I put them up at lunch. So, you are ready to go. And we have about 20 minutes remaining. Let me encourage you to use this time of your classmates' absence to go ahead and do the homework problems. And that way, if you get stuck on something, you can come and talk to me, or potentially to Nate too if you like. Okay? Next time we're together, we will start doing calculations. Realistically, at this point, you should already have read sections 14.1 to 14.4 and 14.5 if you can work it in. Okay? So by next time, please have read up to section 14.5. That is all.